20 some years before people put that together with that's the process that's powering stars.
Mm-hmm.
It was the rearrangement of those nuclei, not atoms. That's why Kelvin wasn't wrong. He was working with the wrong assumptions, right? So fast forward to today, like what would this mean, right? Well, there's a couple of things like this that sit out there in physics, and I'll point out one of them, which is very interesting. We don't know what the hell makes up 90% of the mass in the universe.
Mm-hmm.
So the search for dark matter, right?
Mm-hmm.
What is it? We still haven't discovered it.
Yeah.
90% of the mass of the universe is undetectable. Like what?
And then and dark energy, and again, black holes are the window into this.
Well, then black hole. I mean, in some sense, black holes are way better understood than those things as well too. So all it tells us is that we shouldn't have hubris about the ideas that we understand everything. And when we, who knows what the next major intellectual insight will be about how the universe, functions.
And actually, I think Rutherford is the one who's attributed at least that quote that physics is the only real science, everything else is stamp collecting, right? So there's.
I'm sorry, he's my hero, but I'll slightly disagree with that. Yes.
Well, no offense to stamp collecting; it's very important too. But you have to have humility about the kind of disciplines that make progress at every stage in science.
Yeah, exactly.
That physics did make a huge amount of progress in the 20th century, but it's possible that other disciplines start to step in.
Yeah, but Rutherford couldn't imagine like mapping the human genome because we didn't even know about DNA.
Yeah. Or computers, really.
Or computers.
He really probably didn't think deeply about computation.
It's like, is it? Here's a wild one. What if like the next great revelation to humanity about the universe is not done by the human mind?
That seems increasingly
likely.
And then you start to ask deep questions about what is the purpose of science. For example, if AI system will design a nuclear fusion reactor better than humans do, but we don't quite understand how it works. And the AI can't, we know that it works. We can test it very thoroughly, but we don't know exactly what the control mechanisms is, maybe what the chemistry, the physics is. AI can't quite explain it. They just can't. It's
impenetrable to our consciousness, basically, of trying to hold it all together.
And then, okay, so now we're living in that world where many of the biggest discoveries are made by AI systems.
Yeah.
As if we weren't going big.
I say, it's again. I'll point out, like when my godmother was born, like none of this was in front of us, right? It's like we live in an amazing time. It's like, right, like my grandfather, plowed, fields with a horse. I get to work on designing fusion reactors. Yeah, pretty amazing time.
But still, there's humans, so we'll see. We'll see if that's around 100 years. Maybe it'll be cyborgs and robots.
I think we're pretty resilient, actually.
Yeah, no. That's one lesson from life is it finds a way.
Yeah.
Let me ask even a bigger question. As if those weren't big enough. Let's look out maybe a few hundred years, maybe a few thousand years out. There's something called the Kardashev scale. It's a method of measuring civilization's level of technological advancement based on the amount of energy it's able to use. So type 1 civilization, and this might be, given all your work, is no longer a scale that makes sense, but it very much focuses on the source of fusion, natural source of fusion, which is for us the sun. And type 1 civilizations are able to leverage, sort of collect all the energy that hits Earth. Yeah. And then type 2 civilizations are the ones that are able to leverage the entirety of the energy that comes from the sun by maybe building something
like a Dyson sphere. Yeah.
So when will we reach type 1 status? Is get to the level which we're, I think, maybe a few orders of magnitude away from currently. And in general, do you think about this kind of stuff? Because where energy is so fundamental to this, like of life on Earth, but also the expansion of life into the universe.
Oh yeah. So one of the fun, on a weekend when I sat down and figured out what would it mean for interstellar travel, like to have a DT fusion. In fact, I talked about my design class. One of my design classes was how you use essentially a special configuration of a fusion device for not only traveling to, but colonizing Mars.
Mhm.
So, because you talk about energy use being at the heart of civilizations, like, so what if you want to go to Mars not to just visit it, but actually like leave people there and make it something happen?
Mhm.
It needs massive amounts of energy. So, what would that look like? And it actually transforms how you're thinking about doing that as well too. Oh yeah, so we do all those kinds of fun. And actually, it was a fairly quasi realistic actually
So
scenario.
do you think it'll be nuclear fusion that powers the civilization on Mars?
Well, what we considered was something. So it turns out that there's thorium, which is a heavy element.
Mhm.
So it's a so-called fertile element that we know. We still know fairly little about the geology of Mars and in a deep sense, and we know that there's a lot of this on the surface of Mars. So one of the things we considered was what would happen. That it's basically a combination of a fusion device that actually makes fuel from the thorium.
Oh,
But the underlying energy one was fission itself as well too. So this is one of the examples of trying to be clever right around those things. Or what is it? This also means is like in interstellar travel. It's like, oh yeah, that looks almost like impossible basically from an energy balance point of view. It's just because like the energy required that you have to transport to get there. Almost the only things that would work are DT fusion and basically annihilation. It's like Star Trek, right? That's
so
what it,
your sense is that interstellar travel will require fusion power.
Oh, it's almost even impossible with fusion power. Actually, it's so hard. It's so hard because you have to carry the fuel with you, and the rocket equation tells you about how much fuel you'll use to take. So what you end up with is like, how long does it take to go to these places? And it's like staggering, periods of time.
So I tend to believe that there's alien civilizations dispersed all throughout.
Yeah, but we
the
might
universe.
be totally isolated from them.
So you think there's none in this galaxy? So like, and I guess, and the question I also have is, what kind do you think they have nuclear fusion? It's like, is the physics all the same?
Yeah. Oh, the physics is all the same. Yeah. Right. So this is the Fermi paradox. Like, where the hell is everybody in the universe? Right. Well, there's the scariest one of those is that I would point out that there's been, there's, order of many tens of millions of species on the planet Earth, and only one ever got to the point of sophisticated tool use that we could actually start essentially leveraging the power of what's in nature to our own will. Does this mean that basically this means so almost look, there is almost certainly life or DNA equivalents or whatever would be somewhere. I mean, just because you just need a soup and you need energy and you get organics and whatever the equivalent of amino acids are. But most of the life on Earth has been those are still amazing, but it's still like it's not very interesting. Are we actually